You know when you click Buy Now on some random item online and it just shows up at your door like a day or two later? Ever stop and wonder how that one thing found its way out of a warehouse the size of a city block? Well, it's not magic. It's actually a fascinating puzzle of logic and efficiency. And today, we're going to pull back the curtain on the hidden logic that gets your stuff, well, to your stuff.
So when you look at a warehouse, what do you see? Right, shelves, boxes, a whole lot of stuff. But in the world of logistics, this space is basically a high-stakes chessboard. Every single movement, every step a worker takes costs cold, hard cash. The name of the game is to get you your order in the fewest moves possible.
And this right here is the golden rule, the principle that drives everything else. In the industry, they say, travel time is waste. Think about it. The time a worker is just walking from point A to point B costs money, for sure, but it doesn't actually add any value to the thing you bought. So the entire operation is built around one single goal, crushing that travel time.
Okay, so if you had to guess the biggest expense for running one of these massive buildings, what would you say? The rent? Maybe the inventory itself? Well, the biggest cost is actually something way more fundamental, and it's probably not what you're thinking.
Yep, you heard that right. It's not the building, it's not the products. The number one expense is labor, and specifically, the chunk of that labor spent just walking around. It's kind of wild when you think about it, but getting this one thing right is the key to the entire operation.
To make this real, let's look at a company like McMaster-Carr. They distribute hardware, tools, you name it. We're talking over 450,000 different items. And their customers? They're people on construction sites, in factories. They need their parts like yesterday. An order for just a handful of items gets picked almost instantly. That means for every single one of those small orders, a worker has to find a brand new, unique, and super efficient path through a literal maze of products.
So, if finding the absolute shortest path is the billion-dollar question, what would the perfect answer even look like? Well, it turns out this isn't just a warehouse problem. It's actually one of the most famous and most difficult puzzles in all of computer science.
This puzzle actually has a name, the Traveling Salesman Problem, or TSP for short. It's a classic. Picture a salesman who's got to visit a bunch of different cities. What's the shortest possible route that hits every city just once and gets him back home? That is the exact same problem a warehouse worker or a picker faces with every single order list they get.
So why is this so mind-bendingly hard for a computer to solve perfectly? Well, for starters, there's no magic formula that just spits out the best answer every time. As you add more and more items to an order, the number of possible routes just explodes exponentially. And even if a computer could find that perfect path, it might be so complicated and weird that there's no way a human worker could actually follow it.
Okay, so this brings up a pretty obvious question, right? If cutting down on travel time is the number one priority, why isn't every single warehouse on the planet using supercomputers to solve this traveling salesman problem for every order?
And the answer is, honestly, surprisingly low tech. The software that runs the warehouse management system, is basically a giant glorified spreadsheet. It knows what is on a shelf, but it has absolutely no idea where that shelf is in the physical building. It's like having a list of every address in New York City, but no map. Without that map, that geometric model, calculating the shortest path is literally impossible. So if the perfect solution is off the table, how do these places actually operate so darn efficiently? Well, they rely on solutions that are simple, practical, and frankly, good enough to be great.
Instead of chasing perfection, they use something called heuristics. Now that's just a fancy word for simple, smart rules of thumb. Rather than trying to calculate a unique, perfect path for every single order, they lean on a few standardized, predictable routes that are super easy for workers to learn and follow. Let's check out the most common ones.
First up, one of the most common methods is the serpentine path, and it's pretty much exactly what it sounds like. A worker just snakes their way up aisle 1, down aisle 2, up aisle 3, and so on. It's simple, it's totally predictable, and it lets you have really narrow one-way aisles, which saves a ton of space.
But, and it's a big but, there's a major flaw here. What if your order only has items in, say, aisle 2 and aisle 5? Well, with a strict serpentine path, the picker might still have to walk all the way down aisles 3 and 4 just to follow the route. And that is pure wasted travel, the exact thing we're trying to get rid of.
So to fix that, you get another really popular method, branch and pick. In this system, the picker follows a main path, or a central highway, if you will. They only branch off and detour into an aisle when the order list says there's something in there for them to grab. It's way more flexible and avoids all that wasted travel between the empty aisles.
Okay, so we've got these basic roadmaps, but this is where the real genius kicks in. It's how warehouses layer human intelligence and really clever design on top of these simple paths to make them even more efficient.
All right, now this is where things get really wild and kind of counterintuitive. You'd think a modern, high-tech scanner would always be better than a piece of paper, right? But in a lot of these cases, a simple paper pick list actually wins. How is that even possible?
Just take a look. A paper list shows the picker multiple items at once. This gives them what you might call a global view. They can see what's coming up and use their own brain, their own knowledge of the warehouse layout to plan ahead. They can think, okay, I'll grab this, then cut across to get that one over there. They're optimizing on the fly. A scanner, on the other hand, only gives them a local view. It just says, go here next. There's no room for human ingenuity.
And here's another layer of simple genius that works beautifully with that branch and pick method. It's all about smart product placement. I mean, think about it. If your most popular, fastest-selling items are stored way in the back of the aisles, every picker is forced to take these long detours. But if you're smart, you store the most popular stuff right up front, close to that main path. That way, most pick trips become these super short, super quick detours. It's a simple design choice that has a massive impact on efficiency.
So these clever heuristics and smart designs are how things get done today. But what about tomorrow? What would it actually take to achieve that perfect, mathematically optimized path we were talking about earlier?
What's really stopping every warehouse from going full-on optimization mode? Well, it really boils down to three big things. First, the software itself needs to get that map, that geometric model we mentioned. Second, you need some way to actually send that complex route to the worker, probably on a screen or headset. And finally, and this is the real kicker, the whole expensive upgrade has to actually save more money than the good enough systems they're already using. For many, the math just doesn't add up yet.
So, when you boil it all down, the big takeaway is this. The amazing speed of modern logistics isn't some story about perfect computer algorithms solving impossible problems. It's actually a much more elegant and I think more interesting story about a balance between simple, robust path designs, smart product placement, and empowering human workers to use their own intelligence to find the best way forward.
And that leaves us with one last question to chew on. As technology keeps advancing, as automation and robots become more common in these warehouses, we have to ask ourselves, will the mathematically shortest path always be the truly best one? Or are there other things, like congestion, workflow, or even the human experience, that we'll need to start optimizing for next?